Good morning, everyone, and you are again back to my class where I am solving numerical problems based on electrostatics. In this problem, it says that two identical spheres having charges of opposite sign attract each other with a force of 0.108 Newton when separated by zero point 0.5 meter. The spheres are connected by a conducting wire which is then removed and thereafter they repel each other with a force of 0.036 Newton. What are the initial charges of the spheres? We have to find out Q1 and Q2, and there are two assumptions given in the question which we'll be doing part by part. Let's begin to do it. Here says that two identical spheres having charges of opposite sign that attract each other. Okay, so we can do it here. Let plus Q1 and minus Q2 be the initial charges of the two spheres. On the two spheres. And the question says two identical spheres having charges of opposite signs. Therefore, we have plus Q1 and minus Q2. Naturally they will attract each other because they are opposite in direction. Hence, first part, the assumption says that when the two spheres attract each other, that is when two spheres attract each other, then force is equal to Q1 Q2, that is K Q1 Q2 upon R square. That is, force is given to you 0.108 Newton. That means 0.108 Newton is equal to K is known to you 9 into 10 raised to the power 9. Q1 and Q2 are not known to us, so Q1 Q2 upon R square. The distance is given 0.5 meter, so 0.5 square, and this is your first one. Now if you calculate it further, solve it for Q1 and Q2. If you just a minute. You solve it further here, then you get 0.108 into 0.5 square upon 9 into 10 raised to the power 9 is equal to Q1 Q2. If you solve it, you will get Q1 Q2 equals 3 into 10 raised to the power minus 12. Into 10 raised to the power minus 12. Now similarly you have B segment. In B case, it says that the spheres are connected by a conducting wire which is then removed, and thereafter they repel each other with a force of 0.036 Newton. Similarly, charge on each sphere is how much? Charge on each sphere will be given as, and they share the charge. No? Are charges on each sphere, or the charges on two spheres. You can write it like this. Charges on two spheres are connected by the wire. Are connected by the wire. Okay, now see the question. In the question it says, the spheres are connected by a conducting wire which is removed and thereafter they repel each other. Okay, they share the charges equally. Okay, therefore they share the charge equally. Hence charge on each sphere, will be given as Q1 minus Q2 upon 2, because they share the charges. Now, force of repulsion between them. We'll calculate the force of repulsion, because your question says in the second part, the spheres are connected by a conducting wire who is then removed and thereafter they repel each other, and the force is given 0.036 Newton. The force of repulsion between them, that is F is equal to K Q1 minus Q2 upon 2. Then again second charge is also Q1 minus Q2 upon 2 upon R square, that is R square. Now force of repulsion is written here, that question says that force of repulsion is 0.036 Newton. K is known to you, 9 into 10 raised to the power 9, and you have here upon 0.5 square. Then you have here Q1 minus Q2 by 2 and Q1 minus Q2 by 2. That means Q1 minus Q2 by 2 and whole square. Now solve it. You will get Q1 minus Q2 whole square equals 0.36 into 0.5 square into 4 upon 9 into 10 raised to the power 9. Now we'll continue solving it. Now we'll continue solving it. So you have here Q1 minus Q2 whole square equals 2 into 10 raised to the power minus 6. or Q1 minus Q2, Q1 minus Q2 will be the square root of 2 into 10 raised to the power minus 6, which you can calculate. That is Q1 minus Q2 will become from this assumption you can have Q1 minus Q2 equals 2 into 10 raised to the power minus 6. Now we can calculate Q1 and Q2. How? We can use the formula. We know Q1 plus Q2 whole square is equal to Q1 minus Q2 whole square plus 4 Q1 Q2. The formula is A plus B whole square is equal to A minus B whole square plus 4AB. Now, if you get Q1 plus Q2, you can solve the equation and you will get the value of Q1 and Q2. So Q1 minus Q2 we have calculated 2 into 10 raised to the power minus 6 square plus 4 into Q1 Q2 we have calculated recently, that is Q1 Q2 is 3 into 10 raised to the power minus 12. 3 into 10 raised to the power minus 12. Now solve it. You will get Q1 plus Q2. Q1 plus Q2 will be 4 into 10 raised to the power 4 into 10 raised to the power minus 6. So this is your equation 1 and this one is equation 2. Now since the equation 1 and 2 here you can write, since the equation 1 and 2 Q1 plus or Q1 minus Q2 is given to you 2 into 10 raised to the power minus 6. Q1 plus Q2 you have calculated, that is 4 into 10 raised to the power minus 6. Now add these two equations, you will get 2 Q1 is equal to 2 into 10 raised to the power minus 6 plus 4 into 10 raised to the power minus 6. Therefore, excuse me, Q1 is equal to 2 is common, you get 10 raised to the power minus 6 plus 2 into 10 raised to the power minus 6 upon 2. This 2 and 2 gets cancelled. You have Q1 is equal to 3 into 10 raised to the power minus 6 coulomb. And similarly, you can calculate for Q2. Q2 is 10 raised to the power minus 6 coulomb. This is your desired answer. The question is simple. Once it is saying force of attraction, use the formula. In second part it says force of repulsion. In the force of repulsion, two charges are shared charges, so each charge becomes Q1 minus Q2 by 2. And if you are still having any problem, please contact me at 94786-24982 or mail me prashantlal1961@gmail.com. Thank you very much.